we suggest you alternative solution with Zoom. And welcome to our first solution architecture community meetup. My name is Andriy and I'm senior solution architect from EPAM company. And today we will introduce our community and we will talk about some technical topics. You may ask your question in English in chat, in this case in Zoom chat. You may ask speakers or me as an organizer, and we will answer your questions after each topic. So also I'd like to notify you that we don't allow hateful, racist and political comments, spam and content that promotes services or products. So be careful with your comments, please. I give the floor to Yevgen Mospan, who will introduce our community. So Evgeny.
Thank you, Andrei, and good afternoon, dear participants. One more time, sorry for these technical issues. I do really hope that you can see my screen, and would be grateful if you put something into the chat like plus or something else, just to check that we are communicating. Oh, thank you guys, thank you. So today I want to talk about the solution architecture community and basically who are we, why we are doing that, and so on and so forth. So before we start, I would like to talk about our today's agenda. So there will be two main topics. First of all, I would like to tell who is solution architect at EPAM, and not you can actually harmonize your understanding of who we think solution architect is. And then I will tell you what we are doing to build the solution architect community, not only inside our company, but actually a global one. So who is solution architect? So first of all, I would like you to understand that this is not like a usual person. So it's really a skillful person that is focused on technologies, and it's not more a usual software engineer anymore. It doesn't mean that it stopped. So there is no coding in life of solution architect. It should be there because we all need to stay in touch with the reality and not to become so-called an ivory tower architect, when we just draw the schemes and then let somebody to implement them. So, and that is why the second important skill is basically focus on the business needs. There is no good or bad architecture. There are always architectures which solve particular business problems or do not solve them. So there is no like real bad cases of using this or that architectural style. So monolithic architectures are not bad. So sometimes they do not fit business requirements. And of course, when we talk about the solutions, somebody needs to communicate them and to present the solution to the customers. And again, this is a solution architect. This guy is also need to be a technical leader in the team. And this is somebody who is go-to person in the projects or in business units or in the community. So this is a really experienced person to whom everybody is coming and asking questions. Proactiveness is also one of the most important skills because technologies are changing really rapidly. You know, you all know it. So business requirements are not constant. So they also changes through the time. And that is why we need to be proactive in order to have an opportunity to introduce right decisions in the right time. And this is, of course, leads to the fast learning, because without an ability to understand the technology really quickly and understand the pros and cons, it will be actually hard to use modern solutions in the architectures. Fluent English is must have, so it's like common in IT, so there is no rocket science here. And So what do we have in terms of levels of architects inside our company? And because not all architects are the same, so they are different as well as engineers. So we do have about 6 levels for solution architects, and as you can see on screen, they differ from the point of readiness to take some challenge and to face the project of particular size. So we start with software architect, which is basically ready to go outside the usual development process and to become somebody who can lead the technical stream itself. Then it is a solution architect level 1 with a wide expertise coming to the maturity on the level 2. And level 3 is basically this is real exposure to the customers. So these guys are considered by the customers like a top-notch experts. And everybody, guys, please go on mute because I hear the echo. So they go to the clients face-to-face and communicate them on daily basis. Level 4 and level 5, it's more about strategic vision of how the company needs to develop its services and what should be proposed to the customers. We do invest a lot into growth of our solution architects, and we do have lots of programs inside the company. So I would not stop a lot on them. So basically, we even created this so-called solution architecture school in order to simplify life for the lead software engineers to be promoted to actually architecture expertise. And for the architects themselves, we do propose university in which we give a chance to pass international certifications, so on and so forth. Mentoring is also an important piece of this growth because this allows you to communicate with more experienced person, with persons with different skills, with different experience, and get new skills quicker. I wanted to have one complex slide in this presentation. So it will be only one, and it's mostly for offline reading. So it shows how we see different flavors of architects that need to be present on modern projects. And even more, we also consider that architects are probably the best guys to become consultant, in this case, technology consulting. And the main difference between architect and consulting, it can be explained by very simple example. So if you train your team, you are the architect. If you train customer, you are a consultant. So let's go to solution architecture community. And basically, I would like to present you a communities at platform one more time, through which you have actually received all these notifications. So we do have there a landing page for solution architecture community. And exposing it, we basically want to pursue two main goals. So first of all is to share best practices across companies and build horizontal connection between architects. So it's not an internal community of EPAM, it's basically global. So we invite you to participate in our events as a organizer, as a speaker, as a participant, so which works better for you. So what do we have on the communities at platform? So we do have, of course, talks. So this one will be there as well. You can actually go through what we have already published. So we think that this is really relevant information about recent technology trends, recent news that happened in the architecture practice, and how we actually adopt it inside our company. We publish a lot of articles, and basically we want to explain how to become a solution architect. So what steps to perform, and we try to actually show real life of the architect when he works on the projects, because we are all real people. So that is why we want to share this experience in order to mystify demystify some probably rumors about what architects do, what they do not do, and so on and so forth. We also have useful materials. So it's a guide how to become a solution architect. We do have a library of books. So we do really hope that will be useful for you. Please follow these links and you will get more information what is there. And one more basically notification that we would like to do today is that next week we as a EPAM start that conference. So this is the global virtual conference powered by EPAM. It will be going during 1 week, starting from October 18. We do have a lot of talks there, but specifically for solution architects and basically technology guys, we prepared focused technology practice collection, where we gathered the most interesting talks from those 500 ones, and actually try to give you a space where you can get recent news in a really comfortable way. So I want to welcome you one more time on this first event of Solution Architecture Community Global. I do believe that it is important to build such communities, and I do really hope that you will become an active members, not only as a participants, but in all other possible roles that will appear while our community will be developed. If you have any questions, please post them into the chat. I will try to answer them, and I hope that Andriy will help me to moderate it.
Yeah, we have several questions, so I will ask you. So first one from Georgi, can English level B2+ be considered as a fluent English?
It really depends. So it depends on what organization gave you that level. But basically, what is important to understand is to have fluent communication on technical topics for solution architect with your clients. So if you do it on daily basis, then you have enough English skills to become a solution architect. For consulting guys, it's a little bit more challenging because it's not only about fluent English itself, it's about like native speaking, and without actually tight contact with the native speakers, it is almost impossible to build it. And one more important piece here is basically cultural difference that all we can have comparing to our customers. So it's also should be addressed in some way. So simply saying B2 is a bare minimum. In our understanding, it should be, of course, improved, but after B2, we have like native speakers, so it's C1 and C2, so it's not really easy to get that level.
Okay, thank you. Next one from Tatiana. She has two questions. Let's start from the first one. Does SA at EPAM or in general responsible for the project failure?
It's for me, there is no person who is like one person who is responsible for success or for the failure. So it's all about the team. And of course, architect has his own area of responsibility. So he is responsible for the architecture. If his architecture doesn't work, then it is his failure. And basically, it is his challenge to make the difference into the architecture in order to make it work. Sometimes it happens that implementation cannot be that great. And in this case, architect should also help the team becoming a technical mentor, sometimes solving some task himself, and so on and so forth. But mostly, so technologies, it's not like a very big problem because technologies work in a real predictive way. So you can always isolate the problem, try to actually tackle it from different angles, and you will solve it. More complex problems are usually related to the organization of delivery process itself. And the architect also participates in the delivery process, but he is not accountable to make it successful, because it's a role of different persons on the projects. So in our case, in case of our company, it's delivery managers, simply saying managers. But architect is a technical manager as well. So some portion of responsibility is also on his shoulders.
Okay, and second part of this question is, what happens with SA if his architecture doesn't work at the end? Will he be punished?
To be really honest, I don't know such cases when somebody is being punished, because it's experience itself. So bad architectures is your experience. So people tend to make errors, and mistakes. So there is no person who didn't make any mistake in his life. So it's okay. For me, like a mistake in architecture, this is not a problem. The problem when you ignore it and trying to like play in a finger pointing game and to explain that it is not your fault, it's somebody else's fault. So for me, if person can face the issue and solve it, then it is okay.
Mm-hmm. Okay, just one addition. So this architecture will be signed off by somebody, by delivery manager, for example. So it will not be only your fault, like you said in your first part of this question. So it's difficult to find one person who broke everything. So you may create better architecture, but if you have delivery manager who signs off it, he will not sign off it. So that is why I can say that it's some shared responsibility of the team, like Yevgeny said in the first part of the question. So next one question from Aitor. Sorry for pronunciation, maybe it sounds different, but what about systems? The only path to become SA is from software engineering?
For SA, and I probably do not understand question in the way that you're formulating it, but let me explain what do we have as a different flavors of architects, because solution architects, they are generalists. So basically, these guys have wide vision, but of course, right now, there are some specific areas where should be focused professionals like security architecture. So you do not need to be a software engineer to become a security architect. Of course, if you are experienced DevOps, then you can be infrastructure architect. We call it inside the EPAM system architect. Sometimes it's confusing, but actually, so it can be infrastructure architect. Then quality engineers. We do also have quality engineers inside the company, and it is also an important role on the projects, because those colleagues can build the CI/CD process in the way that it will guarantee the quality. So another example of an architect that we have distinguished from other ones is data solution architect. So those guys are focused on the data itself. And it's really hard to imagine the project without data. So all architects have actually connection to it, but data solution architects, they actually focused on processing, on transforming and presenting the data that exists for the particular business. Hopefully I've answered your question. And again, simply saying software engineering is not the only route from where architect can appear.
Yeah, I may add that even QA has their own architects, because sometimes even QA needs some architecture preparation. for example, to prepare some test strategy or something like this. And also another example is architect from business analyst. So it can be business architect. So it happens very often. And also SA is not only one way to be promoted, because we also have advanced engineering branches, system engineering branches that allows you to grow in your discipline. We have another one question from Tatiana. She asks about this situation with failure architecture. Does DM have power and let's say at EPAM? We said that he signed off architecture.
Okay, so it's like a question about the hierarchy. In my eyes, it's like not a very good way of thinking on how you need to work on the project, because in this way you are trying to understand who will be guilty if the project will be not successful. In my eyes, it's better to stay on the positive side and to invest as much effort as needed into the project success. Technically, DM has a power on SA because he is ultimately responsible for the project success. But in reality, so personally, I do have a really good relationships with the delivery managers, and they always listen to my opinion. I listen to their opinion, and we try to find a compromise, because it is not possible to do everything in a certain portion of time. So we need to prioritize things and actually invest into the project success. In strong hierarchies, it will be challenging to start projects from scratch, but if we talk about long-running project, probably it will work. So Tatiana, hopefully I've answered your question, but not directly, of course. So I've shared only my my own experience.
Okay, thank you. I don't see any other questions in chat. Somebody, not somebody, Katalin asked to pass links to the chat, and I will do it during the second part.
And I see one more question about successful solutions. We will do this in scope of our community, so stay tuned.
Yeah, and the second talk will be exactly about success solution. So let's switch to it. So Andriy, Dmitry, your turn.
Thank you, guys.
Thank you, Yevgeny.
Hello.
Hello. Good evening. Can you hear me, Andriy?
Yeah, we can hear you.
Can you hear us? That's great.
Yeah.
So let me start sharing my screen. Please let me know if you can see it.
Yeah, we can see it.
Great. So let's start our journey to serverless patterns and best practices in AWS. And today, two people will conduct this presentation for you. One of them, it's me, it's Andriy and I am from Ukraine, Kharkiv city. I'm a senior solution architect at EPAM. And my primary focus is on microservices and serverless approaches, projects, etc. Dima, your turn.
Hello, everyone. I'm Dima Pasko. I'm from Kharkiv, Ukraine. Have more than 17 years experience in IT and 6 of them in software architecture. And now we are going to discuss what's interesting we found in serverless design.
Thank you, Dima. And before the main chapter, I would like to start with the discussion of what serverless is really. And probably you remember this picture, the journey from the bare metal to functions. And it's like an often case when people talk about serverless, they usually say functions, Lambda, etc. But if you take a look into Wikipedia, serverless means a little bit more than just functions. So Wikipedia says it's a computing engine. It's a model. You don't care about servers underneath. A cloud provider takes care about all the servers, and you just run your code on top of managed servers. And if we think about the serverless services in AWS, for example. We will remember like services like Aurora, RDS, or it's a database managed service, or it could be a step function, which is a BPM engine, or it could be DynamoDB, which is NoSQL database, or it could be API gateway. It could be a Fargate technology to run ECS or EKS tasks without servers, and etc., etc. So actually, the landscape of serverless services is quite wide. So don't narrow it to 2 functions. And now let's start with our main chapter, the business cases. Dima, please step in.
Yeah, hello everyone. I'm going to discuss what the business cases we do have for serverless. Next slide, Andrew. And we have 4 of them, and all of them united by the same idea, bringing business value, focus on business value, not on infrastructure. Let's go from the first one, a faster time to market. All of applications consists in a lot of layers, contains a lot of layers: physical infrastructure, compute level, storage, queues, and on top of that you have your business logic and your API. So moving all layers below business logic and API to serverless providers, in our cases AWS, allows you faster bring your product faster to market. And so you're focusing on your most important part of your application starting from day one. You're productive from day one. Of course, you could be faster than your potential competitors. Another one, it's reduced cost. Serverless provides quite unique pricing model. For example, when you have when you're paying for virtual machines or for containers, you're paying per hour basis, and of course you maybe not have full utilization on top of this. For serverless, you're paying only for your utilization. So it means that in real life, whenever your virtual machines are loaded about 15–30%, which means that you have 70–85% utilization loss. Even some business models based on this utilization ideas, for example, other cloud providers, they are selling their data centers because you know that utilization won't be so high in terms of resources. So this paying only for your utilization idea allows you to reduce your cost. And of course, it's you're paying even in milliseconds, and because you delegated your physical infrastructure level to the cloud provider, there are no hidden costs such as platform updates, so you don't need to update your Kubernetes and some external security patching of your operation system. So it's not your problem. And from real life experience, we are working for in insurance domain for insurance company. We have a quite stable, predictable load, and in our cases, for example, I'm still discussing reducing cost business principle. In our example, you're creating new environment, for example, staging, and you want to have this environment exactly the same as production. For example, if you would have a cluster of virtual machines, and you would have a lot of machines for staging and for production. For staging, you won't get this load, this utilization like you have in production, but you still would like to pay it because you want to try your scaling and other features. It's not a problem for serverless workloads. So you're paid in our situation, we're paying about 100 times less for this kind of environments because we don't have a lot of utilization, and they're exactly the same as in production. Let's talk about The third item, improved reliability. Of course, the main idea of serverless is that you could scale, you would have your lambdas automatically provisioned whenever you would need it, so you could scale to infinity and back. So whenever you have load, AWS will start automatically provision lambdas for you to support your availability, to support your workload. So at the same time, when you don't have any requests, so it will be automatically shut down. So and you would have a very smooth reliability. Of course, you could implement this this reliability type in a similar way with auto scaling groups, for example, for traditional computes, but it won't be so smooth, this reliability curve. It would be steps like you see in a graph. And the last one business case that I would like to mention is the increased rate of innovation. What is innovation? Innovation is doing a lot of experiments, repeating, experimenting, and trying to kill not successful experiments and grow up what gives you more profit. Serverless, based on our previous business cases, allows you to create new environments for experiment very quickly. They would be really cheap, and they could grow with your load, with your business growth, and at the same time it would be designed distributedly. I mean, so you would have kind of microservices like infrastructure architecture from by design, because you would have a lot of different functions, a lot of different pieces of your software combined. So you would have a microservice design from the beginning, as it would increase your innovation rate. So you could redeploy some part of your application independently. And for me, the most important thing that serverless is a next evolution of cloud computing. So it's a brand new thing that a lot of R&D investment from cloud providers in this area. So, and I decided to add recent news from AWS. They're introducing AWS Graviton processors, ARM-based for Lambdas, which allows you decrease your cost price performance 34%. That's enormous. A lot of innovation is there. So that's next evolution in cloud computing.
Thank you, Dima. And the next topic is serverless design patterns and solutions. And I would like to start with the discussion what actually is already done in scope of AWS solutions. And actually, if you have a task, if you have business problems and you would like to solve it via AWS managed services, I'm pretty sure you shouldn't build a custom solution. You have to go and just to check, probably AWS has already designed a solution for you. And actually there are many already prepared, well-described designs you can just pick up and inject into your enterprise or into your bigger solution. So you can find a lot of building blocks in scope of web applications, mobile applications, IoT, big data, etc. So the main idea, if you have like a task, a challenge to build something in AWS, probably it's already solved. Don't invent a bicycle, just go to the special pages, dedicated knowledge base pages, and just find your solution. For sure, there are some cases when you cannot just take a solution, even if it's already designed by AWS architects. Probably your client work with data, there is a lot of privacy data, and there are some services which are prohibited to use. And in this case, you cannot just take a solution and apply it. you have to find some workarounds to fix like the initial solution. For example, I remember like such a case about step function. So if you would like to process some privacy data in your step function and you suggest to pass parameters from one step to another through task parameters, it appears that anyone with access to AWS console can open history and just take a look at your privacy data. So probably not all of such users are allowed to see those data. And you have to come up with a workaround. So don't invent a wheel and just look up, and probably someone has already solved your challenge, your solution. The next topic I would like to discuss, it's serverless application lens. So at AWS, you can find the well architecture frameworks, and it consists of like 4 parts. It's well architecture framework, serverless lens, FTR lens, SAS lens, etc. But let me focus on serverless lens. So if you would like to ensure that your solution satisfies all the like best practices AWS has, it implements all the best practices AWS architects recommend. So you can take a look at serverless lens. It's a bunch of questions which are grouped into 5 pillars related to operational excellence, security, reliability, performance efficiency, and cost optimization. So you can go through through the list of all these questions and provide your answers. After that, serverless lens framework will give you a report which will consist of several parts. The brief one, it's your improvement plan. So you can quite quickly see some like high risks, medium risks related to those pillars like security, reliability, etc. And also you can see brief description or what it means and the link to AWS knowledge page. So you can follow this link and you can read detailed description, and probably you can find some recommendations how to mitigate the issue there. It's a brief part. And for sure, you can find there a more detailed part, like 5 sections related to each pillar with detailed description like risks, improvements, etc., with very low-level description. This lens is very useful just to ensure that you haven't missed anything designing your solution. It's like a best practice when you have your solution designed, just to go through the serverless lens, just to ensure you are at good shape, so all best practices are applied. And actually, you can demonstrate such a report to your customer just to ensure that your solution is very high quality. The next topic is about serverless myth, and Dima, please step in and tell us about the myth.
Yeah, I would we would have myths and patterns. I would stress 3 myths on this slide. So, for example, serverless means no servers and hardware. Of course, it exists. You are just not managing it. It will be managed by the cloud providers. But it's this abstraction leaks sometime. So it means you need to configure. For example, for Lambda's RAM, your RAM and CPU, but probably that's it. So you still need to understand the deeps how it works, so it's not a magic, and consider this in your software designs. Serverless is just a Lambdas, so I would say that, as Andriy already mentioned, it's a quite big sets of technologies, including three messaging infrastructure, API gateways, DynamoDB. So whenever you design serverless workloads, you would use this technologies very heavily. So you need to understand opportunities that the technologies bring to you. And serverless is not always cheaper. It's, for example, whenever you're deploying very, I would say it's very depends on your workload style. And for example, for specific domain for tech and for stock exchanges, where time to response very important, and you have very many you have a lot of calls, your utilization, I know, 99%, so your price, your total cost of ownership will be not effective in serverless workload. So
right. And Dima, let me reveal one like insight about the first myth. Like later, Dima will like provide an example when you really have to think about the infrastructure, even if you work with just Lambdas.
Yeah, and I'm going to share too where you could optimize your RAM and CPU sizes. Right, next slide. I've added pictures of Sirens and Odysseus to the slide, because every time when Lambda runs, he forgets everything that was in previous run. It doesn't save state. Could you mute your mic, please? It doesn't save states between runs. So because actually it could be run in different parts of the cluster, and it means that you shouldn't use in memory, or you shouldn't consider in memory or Lambda storage as your main storage. So please use external storage opportunities in this case, because like in Siren, you will forget everything. So please pay attention on Lambda specifics. So you need to understand how you run what is opportunity of serverless technologies brings to you. For example, there are a lot of limitations. You should be aware of this. Maximum execution time, request size, this kind of restriction. And I'm going to talk about other other restrictions. And otherwise, you could burn your wings like Icarus on the picture. And next one, it's about my favorites, bringing your favorite stack to the Lambdas. We already have a few comments about cold start issue with serverless. Again, for specific, it's not always in a requirement to have this very quick start in your application. For example, if you're doing this integration jobs for a specific amount of policies from one subsystem to the other subsystem, getting some cold start issue, getting some additional milliseconds during your cold start, maybe it's not an issue. But again, if you have a very performance-oriented workload, it could be an issue. So whenever you're choosing stack, you could write Lambdas in a lot of technologies, starting from .NET, C#, then Go, TypeScript, Node, and so Python, of course. Please choose technology that suits your team, and of course would allow you reduce your memory consumption, reduce your cold start, and reduce your CPU requirements. But again, in some cases, when you have very specific libraries that developed in Java and support the specific document format, so maybe for this case you could choose language that will allows you faster to implement and go to the market. And I had a picture of Yasona Argonauts on this picture because they have a lot of troubles and a lot of adventures. So you could have a lot of adventures troubles in choosing your technical stack. And the next myth is about multi-threading. Please consider do not use multi-threading in your lambdas. You could make orchestration with using AWS Step functions. You have message brokers. You have queues. So again, whenever you are making it go from one lambda to another lambda and waiting for result, you're paying for this time, and it's not cost efficient in most of the cases. So if you King Midas, like on picture, you could pay all the bills, but otherwise, please consider other options to orchestrations than having multi-threading lambdas. Andrew, what you have next?
Thank you. Yep, thank you very much. This story about myths are really interesting. And now, like the game time. Let's discuss serverless designs and some errors you can receive designing some solutions. So let's just imagine we have a client who has a legacy internal service, and the client wants you to build an integration between the legacy service and between like third-party API, which is somewhere far from you, and the integration is to be built across internet communications. Also, this integration will have to provide some security, some level of security, and also do some transformation. So we have these three constraints for this business case. The first one, the API of internal service cannot be exposed to internet. So it must be secured in scope of demilitarized zone. The second constraint, that this internal service cannot be modified. It's so old. It's built on COBOL, probably CI/CS, etc. It could be in mainframe, so nobody knows and remembers what it's about. And we are not going to touch any line of code. And there is a third constraint. This internal service goes to maintenance every night, every weekend, etc. So these are constraints, and we have to build an integration between these two APIs according to those constraints. Also, we have a bunch of requirements. The first one is just about authentication, OS to 0, well known. Also, the load on this integration is not significant, just up to 100 calls per day. So it's like nothing, almost nothing. The request is up to 10 megabytes. The request goes from the external service to the internal service, and it's up to 10 megabytes. Also, the client wants us to build a very cost-efficient solution. So if it does nothing, we pay nothing. And also, the client wants 24 hours and 7 days availability for this integration. So keeping all that stuff in mind, an architect came up with such a solution. Let's take a look at it and what it means, and just check if it satisfies all the requirements. So we have the external service. It sends a request through the internet, and the request comes to API gateway. API gateway uses Lambda, which integrates with enterprise SSO to check the credentials the request came with, and if authentication and authorization passed. This gateway sends the requests down to Lambda function, which accept messages. And this Lambda function writes the messages itself into S3 bucket, and also writes a record for audit purposes into DynamoDB. So it's like message number and status received. And at the other end, we have a Lambda which runs on schedule, reads the audit information, unprocessed messages from the Dynamo, unprocessed records from the DynamoDB, takes the messages from S3 bucket and writes to the internal service. So let's take a look. Authentication we have here. 100 calls, for sure, it's supported. 10 megabytes, it's not big number. Cost efficient solution, right, it's serverless. 24/7 availability, right. It's a serverless solution, it's always the public cloud provider is responsible for the availability of all these services. Constraints. API is not exposed to the internet. We have like a wrap on top of the internal service API. We didn't modify the internal service. And this Lambda, which runs on schedule, allows us to write into the internal service only when it's up and running, and like skip time frame when it's on the maintenance. Yep, is it good? Actually, remember what Yevgen said at the very beginning of this presentation. So there is no good or bad architecture. There is architecture which satisfies customer requirements and an architecture which doesn't satisfy. So let's take a look at this design, and please write into the chat. Do you see any error in this design, or it's okay? So probably I'll give you like 30 seconds to think through it. And while you're writing into the chat, I have an interesting question to Dmytro. Dima, yep. Could you please tell me how many developers does it take to change a light bulb?
Infinity of developers.
Okay, Yevgen, are you still on call?
Amount of developers.
Okay, the one answer is
okay. Maybe two. One is changing light bulb, and another one reading documentation.
Okay, two. Another option. Yevgeny, are you still on a call? On this call? Do you have like
probably not?
Answer?
Maybe Andriy could help us.
Andriy, Haritolenko.
So the question: how many developers you need
to change a bulb? To change a light bulb? Yep.
At least one.
I would say probably these options are not correct because it's a really hardware problem. It's not. It doesn't relate to any source code. So actually, it was a joke. And let's take a look at the chat. What do we have here? Let me scroll from the bottom to the up. It's not responsibility of the check credentials. It's debatable. S3 for queue of requests and queues like SQS are better. We are not. Remember, I said we're not talking about good or bad, which is better or which is not so good. We're talking about, does this architecture satisfy this requirement or not? If it satisfies, so at least it doesn't have any errors. Okay, so I can see people writing, so probably I have to go from the top to the bottom. I'll answer this question a little bit later. Okay. It's not about it. These are questions to Dima. We'll answer after the presentation.
Very popular choice is 10 megabytes doesn't satisfy 6 megabyte Lambda limit.
Right, great. Thank you very much. So I won't be listing all these options. You're absolutely right. Great audience. Yeah, that's right. API gateway supports payload size up to 10 megabytes, but Lambda supports just 6 megabytes. So one of our requirements is not satisfied, and it means this architecture is like bad. So let's think about another option, and probably this option satisfies the requirements. So let's take a look at it right now. So we have the same API gateway on top of our legacy API. We have the same Lambda to do some authentication stuff via SSO. But Amazon API Gateway writes messages directly to S3 storage, and S3 storage generates events about new files in a bucket. There is AWS Lambda which listens to those events, and if it sees a new event, it creates a new record in Amazon DynamoDB for audit purposes. And again, there is a Lambda which runs on schedule, and it reads unprocessed records from the DynamoDB, takes data from S3 buckets and sends to the Server API. So let me highlight one fact here. This Lambda doesn't read the whole message because it's like up to 10 megabytes. So this Lambda opens the connection to the internal service, reads some data, bunch of data, writes to the internal service, reads data, writes to the internal service. So in this way, we satisfy this like request size is up to 10 megabyte requirement. So I'm not discussing here, shall we use queue or something else, but actually I remember there is a limitation on message in a queue as well. What's more important that this design satisfies all these requirements. Is there a better solution? Probably yes. And actually, my last experience was with my architecture group. I had like 15 architects, and sometimes we did integrations which are quite common in general. Before we design it like a general template everyone can reuse, my architects designed right solutions which satisfies all the requirements, but all the solutions were a little bit different. And it's like, it's normal because every one of us thinks in its own way, and some solutions can differ, but it doesn't mean they are better or worse. If your solution satisfies the requirements, that's great. So thank you very much. And there is another topic. It's about serverless and legacy. So it's quite a rare case when you have a greenfield project and you don't need to integrate with all the legacy stuff. Usually at big enterprise, actually enterprise is usually big. At enterprise, you build something new in cloud. You add some capabilities, but for sure there are some capabilities on-prem, and you have to integrate with legacy solutions from your cloud solution. But are they equal? Absolutely not. Serverless solutions are highly scalable, highly available solutions, and they easily adopt a load. What we have at like legacy side? Usually legacy solutions have maintenance window. They can be down at night or at the weekend. They have limited scalability because they are like on real metal bare metal environment. So they cannot scale significantly. Also, because they built on legacy stack with legacy technologies, they have limited concurrency. It could be like, in my experience, I worked with some legacy services which can process one concurrent request at the same time. So if you would like to process 10 requests, you have to deploy 10 instances of that service, and so on. Also, sometimes you can get some unexpected errors, but they're not really errors. Some happens in that legacy stuff, nobody knows about it. If you do retry, probably you get successful response. Also, you get unexpected timeouts, and if you have questions, nobody can ask them. People who designed and built those legacy systems probably already retired. So what shall we do? How can we like marry serverless solutions and legacy solutions? So I would suggest to take a look at resiliency patterns. So it's quite a well-known picture with all the resiliency patterns, but I highlighted, I believe, most important ones to friend legacy and cloud solutions. The one, and probably one of the most important, it's a idempotency. And it means you have to wrap your legacy API with in cloud and build your wrapper API on idempotency principle. So what it means, if somebody wants to write to a legacy system via your wrapper API, any the second, the third call doesn't change anything. If the first call has already did some data changes in your legacy stuff. For example, you make a call to on-prem service and you get response back. Does it really mean that your data is not successfully recorded somewhere? Probably not. So in my implementations, usually I do search for a record, and if there is no such record, I write it down. Also, there are two other quite important patterns. It's asynchronous communication and bulkheads. When you isolate on-prem from cloud path using some message broker, for example. So cloud path can scale infinitely and writes requests to the queue. But on another end, you have like a processor which writes to legacy servers according to schedule, according to their constraints. And there is a third group of patterns which allows you makes integration with legacy stuff a little bit safer. So if on-prem service is down, does it make sense to write again and again to that failed service? Probably not. So you should wrap your calls to the legacy stuff into circuit breaker pattern, which also usually is used with like fail fast approach, with a retry pattern, with timeouts pattern. And in this way, applying all those patterns, you can build quite safe and resilient integration with on-prem service. And this is an example of such integration. So if you're really interested in the details of such integration, there is a link to a dedicated talk about circuit breaker pattern implementation in serverless world. Briefly, it consists of a few parts. It's Amazon API gateway to receive the request to the legacy system, queue to accumulate the messages, Lambda, which writes messages to the legacy system according to limitations like concurrency limitations. And also this Lambda implements circuit breaker pattern and saves failed state into DynamoDB just to fail fast on some requests. And in case of some messages which cannot be processed by legacy system, there is a dedicated dead letter queue those events come to. So again, if you are interested, follow this link and you will find a lot of details there. And now, I believe probably the most interesting topic in this presentation, it's serverless DevOps best practices. And Dima, please step in.
Yeah, we have 7 more slides and not a lot of time, so I will try to be really quick. So for serverless, you need to write quite a bunch of CloudFormation code to automate your workloads deployment. And so to simplify your work, I would recommend to start take a look on serverless application models. It's a framework produced by AWS. It simplifies writing your CloudFormation and it's built on top of CloudFormation. So you have all serverless, most of the serverless build practices are built in right to this framework. So automatically creation of policies and other security best practices. But most of all, it's interesting is you could have a possibility for testing and debugging on your Lambdas on your local machine, and especially it's especially interesting when you could use local stack to have even more services emulated on your local machine. So you could simplify your development development workflow environment with these tools. Another tool is called AWS CDK. So it's AWS Cloud Development Kit, not Software Development Kit. It will allow you to write CloudFormation configurations with programming languages, for example, with TypeScript, JavaScript, Python, Java, C# and Go recently. They've added Go recently, and yeah, that's right. And for example, you need to create 5 Lambdas with 5 queues associated with CloudFormation. You need to copy paste this 5 times, and with AWS CDK you could have a cycle for this, and you could wrap this specific functionality. For example, a API gateway with connected Lambda with specific security. You could wrap up in class, and you could reuse in other part of the application, reuse outside your company, and even more, this high-level pieces with CDK infrastructure code already exists. You could take a look at AWS Solution Constructs, Construct Hub, and CDK patterns. This is 3 major places where you could already find libraries that will help your to implement your serverless infrastructure from bigger pieces. So you could have a you could start not from the scratch from the existing libraries. And yeah, I would really recommend to look at CDK and these libraries. Next point is nested stacks. So when you're in our first implementation, we've started implementing Lambdas independently. So all our most of our Lambdas was had independent CI/CD pipeline. So they they deployed independently. But we find out that we have a lot of problems to have full workload and deployed in the correct way, and then we switch back to the nested stacks. So instead of having all your pieces infrastructure in independent stacks, we bring one bounded contextual application. We describe this workflow as a nested stack. So we said that you should deploy DynamoDB first, then you need to deploy Lambdas, and then API gateway would be the last one, because if you don't have DynamoDB, you couldn't put any data in your Lambda. So it brings atomic deployments to our code. It simplifies a lot of engineering practices. So I would recommend to design your workflows in AWS with help of nested stacks. So you could describe parent-child relationship with help of this tool. We also find out more limits, not specifically on Lambda level. That's limits on account level. So when you're in a big organization, you could find out that there are limits of concurrent execution. Lambdas on your account. So you have, when you have big organization and everyone is running their lambdas, so you may find out your lambda is not running because you reach the limit. And there are other limitations in the functions, and especially in elastic network interfaces and VPCs and N3. So you will find out this limits when you have even medium size of organization, about 100 developers. So I suggest to set up, of course, monitoring on your consumption limits to understand amount of registered machines, concurrent execution. So you need to invest a lot of in this dashboards and alert notifications. And of course, best practice is divide do not have just one AWS account for such a big organization, to divide your account into several pieces as recommended today and by AWS team. So the next one is about AWS Lambda Power Tuning. We already mentioned that you need to invest time on this. Depending on your Lambda workload type, you need to understand what is more important. Is it execution time? Is it cost effectiveness? Is it what is the balance? So this tool running your Lambda by all possible configurations. So and you get a graph. So and you could choose best one in terms of one of the categories that you are interested in. On the graph, you could see that probably this would be effective, quite effective to have a specific RAM size. So there are tools on the market, so you could quickly automate the process. DB connections management. For example, if you, as we already talked on our business cases slides, you could very quickly have a lot of lambdas running, but it's in the same time if you would have RDS connected with your lambdas, you could get an issue with getting so much connections, database connections. So there are a lot of possibilities how you could fix it. Of course, you could use another databases, for example, DynamoDB. But there are also possibilities to use Aurora serverless or RDS proxy specifically to fix this. So it's a known issue, and you will eventually and at the same time it's very quick fixes by AWS. And next slide, what is not covered in our application. So we have a lot of interesting technologies in Lambdas. So Lambda layers, Lambda extensions, and Lambda Docker images. We've tried all of them with different type of success, and we are not covering this scenarios. I will just mention that Lambda layers, probably it's not always good idea to use to share your libraries code, because you would have binary dependencies between lambdas. Sometimes it's hard to manage. But with Lambda extensions are very dedicated to the monitoring tools, and we try to implement, try to use it for resilience. Does it work in our case? It won't. And for Docker images, it's a It's a very interesting idea to describe to your Lambda as a Docker image and deploy it. But there are some restrictions. You need to have a your Docker image registry only Amazon ECR, but they would eventually decrease this limitations, and we'll see. Maybe it's a best way to deploy Lambdas. So that's it for me. Thank you very much.
Thank you very much. And probably we can switch to the questions in our chat.
We have a lot of questions for you. So let's start from the top. Sergey asks, do Lambdas always more cost effective than anything else? For example, if we compare with VM, constantly loaded at 50% and not taking into consideration other costs like operations and support.
Yeah, and I would say, well, we rewrite we had how I would say, we already have some functionality implemented in the classic way. So we've implemented the Lambdas, and we had several accounts for the same functionality. In our case, it was that all serverless infrastructure was several times cheaper than we previously had with containers on Fargate and EC2 virtual machines. So in our case, in our workloads, it's cost effective, and the most interesting it's decrease a lot on DevOps department and so on. So developers have a lot of possibilities.
Also, remember, Dima, we had like a corner case. We had a quite high loaded API, and we calculated that run on pure Lambda will cost like 50% more than load on if you build API on top of a container technology. So you have to carefully calculate what's really suit your needs. Yeah, in general, serverless are more cost-efficient solutions. But if you have high load, probably traditional way to build your applications in container will be more effective, cost-efficient.
Okay, thank you. Next one from Tatiana. When serverless doesn't work, any examples when it's not a good idea to go to serverless?
Oh,
we already discussed it on one of our slides. For example, we've tried to calculate TCO for EdTech business. It won't work.
Mm-hmm.
And also sometimes there are some restrictions related to some specific technologies client side, or for example, client doesn't want to to tie itself to the specific cloud provider. So like Lambda can be just prohibited, and you can use something else like containers or something like this. You can use Kubernetes, but not serverless solutions or managed services, something like this.
And the next one question is also almost about it. Am I right that in the case of high predictable and even workload tools like ECS are less expensive than Lambda, aren't prone to cold start issue, have no execution time limit, etc.? This should be considered in the first place, isn't it?
Absolutely right. For example, if you would like to build responsive user interface, you would like your front-end applications will be very responsible. So you cannot allow yourself cold start. So it means all your requests must be completed in less like 100 milliseconds, something like this. But with Lambda, even if it's warmed, sometimes you can get failure on your response processing.
But again, configuring TC2s requires a lot of time. So you need to have volumes configured in the right way. You need to configure backups. You need to choose carefully what resources would you consume. So you need to have configure all image, think about how you're going to patch your operation system. So while you are implementing and doing this for serverless, you could already implement this and go to the next business issue.
Yeah, and also there is a concern with the number of concurrent lambdas. If you have a very high load, so and you have your container, it will be loaded like 100%, and then slows answer like request processing. But if you use lambdas, they will scale until they limit the hard limits. So it means probably other workloads won't be able even to start. That's why you have to design your solution very carefully when you use lambdas, and you suggest you have spikes or high load during some like time frames, because almost all lambdas run in the same account. So yep, should be very careful with lambdas.
Okay, thank you. Next question, how you suggest to solve PII issue in step functions?
Oh, there are two options there. The first, probably you can come up with more options. The first one, you can just encrypt your data. You encrypt data when it passes through the step function. And you can decrypt it if you would like to process it in some microservice or in some Lambda, and then encrypt it again. And it's not very efficient. And another solution, just to keep your privacy data in a database, for example, DynamoDB, and you pass only reference, only ID through the steps in the step function.
Okay, cool. Next question, I think, is already answered about drawbacks of serverless architecture. Do you have kind of collected statistics of cost comparisons for real life similar projects where which are serverless hosted and server full cloud hosted? If there was a real big advantage in hosting costs after moving solution towards serverless in real life examples, and what's the impact to development phase cost in the case of implementation of serverless approach?
Yeah, I'm preparing this kind of statistics. We are going to establish serverless community internally, and we are going to share our findings with on one of our next meetings. So we are working on this. We are going to provide some. We are going to share our reference architecture and findings in terms of cost efficiency. So this was pretty lightweight talk. We are going to share more details later.
Okay, cool. Okay, let's move down to questions and skip some comments regarding your solution. This solution is only to save data. What about internal service business logic? How business logic works when there is a maintenance? It's about your solution.
It's about
it's about that
task.
Yeah, it's a task. So actually, it doesn't work. So let me quickly answer. So if the internal service is on maintenance, it means we do not write any data into the internal service. So the data accumulates in a S3 bucket and in Amazon DynamoDB. And you see the load is not very high. So probably during the night or during the weekend, there won't be too many like messages to be processed.
Actually, the question was about, is it supposed to read from the internal service? So seems to be not.
No.
Yeah.
Well, that was integration, just one-way integration.
Okay, next one. What if maintenance took longer than expected and Lambda started?
It will fail. There is no like login and monitoring path here. I did it on purpose just to simplify the whole picture, but for sure there like should be some monitoring, some error handling mechanism, etc.
Okay. return back to 10 megabyte limits. What about 10 megabyte requirement? Does it fit throughput restrictions of scheduled Lambda?
Yep, because Lambda doesn't read the whole message. It like opens a S3 bucket and reads a bunch of data, opens a connection to the internal service, writes like 100 kilobytes, then reads again 100 kilobytes, writes to the internal service and repeats until the data, the S3 bucket data is like all processed.
Okay. What is the best serverless architecture for a very common task? After the request, you need to do a bunch of asynchronous but sequential tasks like query a service, put results in DB, send message, etc., and only then return a response.
You have API gateway, SQS, then Lambda, then you're returning back information to the another API gateway or to the same API gateway, something like this. This in your Lambda, you could use additional storage. And also, it's you could run Lambdas in a synchronous way. So please take a look. So it's I would use this API gateway SQS Lambda approach.
Question from me: will step function covers the solution or not?
Yeah. As for asynchronous, so maybe if you, it depends of what you are doing in this in your job.
Right, there are many different solutions. You can implement this integration like in many different ways.
Oh, yeah.
And if it satisfies your requirements, that's
probably
great.
step functions, it would be even better. So I was considering it mostly about API. Yeah, here is a different Lambdas. Yeah, so definitely step functions. So please do not reinvent your own orchestration.
Okay, and we have last question from Alexander. What about full stack? Can we have front end and back end using AWS? And what about development process? Is it faster than other approaches?
It's faster. From my perspective, like serverless approach is faster. About front end, so front end runs in a browser. So the only way I can see how we can use our cloud for front-end applications, we just deploy it in a S3 bucket. We configure a CDN in front of the bucket just to speed up like static content distribution. Probably I didn't get the question, sorry.
I'm not sure that it's about Lambda or for front end. Usually, if you have static website, you may use S3 bucket. For backend, you may use Lambdas, for example. So maybe clarify this question. And we also received another question from Andriy. As I understand, there is no out-of-the-box solution for circuit breaker for Lambda. Is it right? Because in Azure, for example, there is an example using durable functions.
Yep, that's correct. There are some solutions around the circuit breaker, but there is no like circuit breaker solution in AWS. There are some services which include circuit breaker pattern as a capability.
Okay. Yeah. So the answer will be there is no out-of-the-box solution for circuit breaking.
Yeah,
for AWS.
Yeah. For now, maybe it's already exists. It's already.
But yeah,
I think at the moment that solution was built, it was like half year ago, right, Dima?
I would say 1.5 years ago.
So AWS consistently adds a lot of new services, new capabilities. Probably there is something new. So, but I haven't heard anything about circuit breaker pattern implementation in AWS.
Andriy says that perhaps front-end question was about SSR using
Server-side
Lambda
rendering.
Yeah.
Yeah, I haven't worked with this, so I couldn't comment about this front-end, back-end, and SSR.
Okay, so any other questions? I'll give you 1 minute for other questions, and just remind that we will send you a feedback form. So please answer on questions. We would like to improve our community. At least now we have 1 point for improvement with the start of translation. So don't hesitate to write some words to us. So what topics would you like to hear next time? Would you like to be a speaker or something like this? So please answer on these questions. If there are no questions, I would like to say thank you to our speakers, to Andriy, Dmitry, and Yevgeny. I hope it was enjoyable for you, for speakers and for participants, and I'd like to see you on the next event. Have a good time and enjoy our community.
Yep.
Thank you, guys.
Thanks, everyone.
See you.
Thank you.
Bye-bye.
See you. Bye.
Thank you a lot.
Thank you. Bye.